Hi, my name is David Hidden, and today I am going to walk through the cardiac cycle using the Wiggers diagram to show how pressure, volume, valve movement, and blood flow all work together during one full heartbeat. The cardiac cycle represents a sequence where the heart fills with blood and then pumps it out of the body in a very organized way. I will start with atrial systole, which happens near the end of ventricular diastole. During this phase, the atria contracts and pushes the last portion of blood into the ventricles. This brings the ventricular volume up to EDV, or end diastolic volume. Ventricular pressure then increases slightly, but the atrioventricular valves stay open, allowing the blood to move easily from the atria into the ventricles. You can see this little jump right here between the volume and the pressure. Next is the isovolumetric contraction, which marks the start of the ventricular systole. Here, the ventricles begin to contract and the pressure rises very quickly. Once ventricular pressure becomes higher than the atrial pressure, which you can also determine right here, the atrioventricular valves close. Since both sets of valves are closed at this point, the volume does not change, which you can see right here, even though that the pressure is increasing. This phase is important because it allows the ventricles to build enough pressure to push blood out of the heart. When the ventricular pressure exceeds the pressure in the aorta and the pulmonary artery, the injection begins. The semilunar valves open and the blood is pumped into the systemic and pulmonary circulation. As blood leaves the ventricles, the volume decreases, which you can see this deep dip right here. The pressure reaches a peak as well and then gradually declines as the injection slows, where you can see right at this line over here. After the injection, the heart enters isovolumetric relaxation, which signals the start of ventricular diastole. The ventricles relax, causing the pressure to drop very quickly. When ventricular pressure falls below the arterial pressure, the semilunar valves close. All valves are closed again, so the volume actually does stay the same at end systolic volume, or ESV, while pressure continues to decrease. And this final phase is ventricular filling. Once the ventricular pressure drops below atrial pressure, the atrioventricular valves open and blood flows passively into the ventricles. Most ventricular fillings happen during this phase. The volume continues to rise, as you can see right here, until the next atrial systole begins, completing the cycle. Overall, this Wiggers diagram clearly shows how the pressure changes control valve's movement, how valve movement directs the blood flow, and how changes in ventricular volume determines the stroke volume and cardiac output as well. This coordinated process also allows the heart to adjust to different demands while maintaining efficient circulation. Thank you.